who heard the term SameOrigin Policy? Raise your hand. Whoa. There are some people who haven't, so this presentation is also for you, but for the guys who heard the term, it doesn't mean you understand it, so I hope it will change. Okay, so just a quick reminder. Origin is a scheme combined with host and port. So a common example is that you run your Webpack server on localhost port 3000 and your backend on port 3001. And the request between those is cross-origin. So if you haven't set up your course properly, then you will probably get this infamous error, no access control, although origin header is present. Yeah, so a small little detail in IE, this is not the case. Port is not taken into account. It introduces some vectors of attack, but I won't be covering that. Yeah, so SameOrigin policy is not really a clear concept. It's more like a set of rules that say how two websites can interact with each other. So it's quite complex, and in my talk I'll be covering mainly SameOrigin policy in the context of HTTP requests. So one question: why this request, or can this request be successfully executed in the browser? Because on the server we would most likely get in response the messenger's homepage, but in the client, if in the response we would be able to access what the user would see after typing message.com into the address bar, then it would get pretty dangerous, right? So, for example, some popular website could just make these requests and download your messages and have even more data on you. Yeah, so obviously, by default, such a request is not possible. One could say based on that SameOrigin policy forbids making a cross-origin request, which is of course not true. I think most of us had a chance to download jQuery from some CDN, and it worked perfectly fine. So a more detailed definition would be SameOrigin policy does not allow reading data across origins, but it allows embedding and writing data across origins. Let's jump straight into embedding. By intuition, it seems pretty straightforward. Any website can embed any resources, and one thing that it has to keep in mind is that the provider of this resource might be evil. So, for example, jQuery runs in the same context as our JavaScript, but besides that, there's no apparent danger associated with embedding. The case is a bit different with writing, because now if any website can execute such code, it possibly can perform state-changing actions in the name of the user. So let me show you a quick example of that. Okay. Let me run my application. So I bought this domain especially for this presentation, a.com. It was very expensive, believe me. Yeah, you probably don't see much in the back there, so let me increase the size of both. Okay. Do you see it well? On the back? Awesome. So here's a very simple, very ugly blog that I wrote. So maybe the source code will be telling you more than my user interface. So here we basically have an EJS template where we render all the block entries, and based on logged-in parameter, we either display a login form or we display block entry creator form. So on the backend, there are 3 endpoints. One to log in. So we basically check the payload of the request. If there's a correct username and password, then we set the session cookie on the response using set cookie header. Another endpoint is at block entry, where we check actually if this cookie is sent with the request. That's how we authenticate our user who on the audience see some problems right now with this app. I mean, a vector for attack here. Raise your hand. Okay, so it's not that obvious. Cool. Yeah, so we only allow adding block entries for logged-in users, and here we just render our block where we pass block entries and this logged-in parameter based on the presence of the cookie. Let's see it in action. Maybe the network tab would be more helpful for you. Okay, so we can log in. Let's use wrong password. We get unauthorized, and correct password is not very different. Okay, so we're logged in. Let's see what happened actually. Here we see we passed in the body username and password, and on the response there was this set cookie header present. So we now store this cookie. The browser now stores this cookie, and we can add a post. Okay, pretty dumb content for a post, but it works. And there's actually a second website that belongs to an attacker. So, for example, you have gotten this URL in your email. Watch these evil kittens because you love evil kittens for some reason, and you go there. Let's see the source of this website. So you're not so you're prepared. Yeah. So here is just a simple form that goes to a.com. So that's a cross-origin write. And let's see what happens. Some comments. Okay, it's worked or did not work, depending on how we look at it. And does someone have idea why this worked? Actually, okay. So one guy, the one who has talked about security today. So good. Let me just show you what happened, and I might even use this fancy laser here. Oh, cool. So first we logged in, a.com server responded with set cookie header, and now the browser sends this cookie with every request coming to this server. So no matter what client makes this request. So actually, if we look on the DevTools here, we can make this request again, and we can see that this cookie header was actually submitted with the request, and it was done automatically by the browser. As you can see, that's a very simple form. So I was really shocked when I first found out about it, because it's counterintuitive, right? We set the cookie for a.com domain, and it's sent with every request. And it bothered me for like half a year. I could only find on Stack Overflow some really poor answers. Why is that happening? So I decided to ask the guy who actually invented the cookies and implemented them in Netscape. The guy's name is Lumon Tully. Maybe you know him. He wrote this text-based browser in 1992, Lynx. It was one of the first popular browsers. And then he worked for Mosaic, and he was a founding engineer of Netscape, so a true pioneer. And I asked him, the last sentence is what's important. I wonder if you or your colleagues raised the issue of using cookies to authorize state-changing operations. And he answered, my memory is that we did not discuss state-changing operations when cookies were first designed. JavaScript did not yet exist at that time, and it was not possible to perform a post operation without an explicit form on the page and pressing the submit button. So in short words, he said that nobody just predicted it, right? So I think what's important about these answers, that's a very, very simple history of the web, that these features in the early days of web were designed sort of separately. So when people were designing forms, they didn't know about cookies in JavaScript. And the problem is that when such a feature is deployed, we cannot really change it how it behaves because all the websites are using it. So even if you want to create a truly secure web browser, then many websites would stop working there. So actually, there's very little we can do. I think the best we can do is to learn about those intricacies, how certain features behave under different edge cases. And yeah, when it comes to this attack called CSRF that I showed you before, one thing that we can do is to compare origin header. That's pretty obvious solution because we do not want clients from different origins to be able to perform such an operation. I actually implemented it, so let me just quickly show you that. Okay, so I switched branches and I can run it. What changed is I added this middleware here in Express. So this code runs before each handler, each route. And here we check if the request method is post. That's very important because actually the docs say that oh, I have no internet, or you have to trust me on that. That this header is actually sent with every course request because it has to, and with every post request. So that's why we changed for that, because we want this header to be present when our client is making the request, so we know it's him. It's it. Yeah, here there are some edge cases. And the most important part is actually the last condition. We just want this origin to be same as ours. So here, and let's maybe see if it works, this solution. So let's refresh the page. Posts are stored in memory, so they are all deleted. A post, cool, it works for our client, and let's see how it works for the other client. For the attacker's client, okay, we get unauthorized, and that's because you can see I log here path method and origin header, and first when we made the request, this origin was a.com, and here it's b.com. So this seems like a perfect solution. It's only server side, very simple. There are some problems with that. So first, you can see that 3% of internet traffic does not support this origin header. So obviously, this header was introduced when cores were introduced, and there are still some browsers installed on the user's PCs that do not support this header. And there are some people who argue that there might be in the future some different privacy-related context when this header will be set to null. So we sort of cannot depend on it when it comes to security of our applications. That's why there are other ways to mitigate this attack. Very easy way is same-side cookies. Who heard about same-side cookies? Okay, so about 10 people. That's actually a great feature. I really love it. Let me just... Okay, so what changed in comparison to the initial code is and I added this same-site attribute to the setCookie header. And yeah, maybe let's delete cookies, so we know. Okay. So now when I log in and make this request, we can see in the network tab that everything worked. For our client, the cookie was submitted, And for the other client, we get unauthorized. Why? Because there was no cookie. So sort of this header makes cookie behave how they're supposed to behave from the beginning. But the huge problem with that, because that's a great technique that's very easy to support in our applications, the problem with that is that 12% of internet traffic support of internet traffic does not know about this header, so it just ignores this attribute, and this attack is still possible for this 12%. So for a couple of years we won't be able to use that, and that's where final technique comes in. Still recommended for most of the applications, called CSRF token. Yeah, and basically it is a bit more complex, but not that much either. Let me again delete the cookies. Okay, so what changed now is I added this middleware that checks for payload in every state-changing operation. We check for this CSRF token, which should actually be generated for each session that you generate. So when you generate a session ID for a user, you generate a CSRF token as well. Here I have only one user, so it's a bit simpler. Yeah, and important thing is that I actually pass this CSRF token to the JS template, so it's rendered with the HTML in the initial get response. Let's see. Oh yeah, and it is important how I use it in the JS template. I submit a hidden input with the CSRF token. Of course, in your application, you'd probably use Ajax here for making such a request. So you could pass this token in many different ways. Probably your frameworks just support it somehow. Yeah, and let's see this in action. I refresh. I log in. Okay. We can see in the requests payload we have the CSRF token, and now we already know that it won't work for the attacker because he has no way to access this token. But let's see this anyway. Okay, so obviously there is no CSRF token here. But some of you may be wondering, why can't I just go to the if I am the attacker, why can't I just, for example, download just the contents of this HTML, find this CSRF token, and pass it in my request. So let's create a quick async function here. I will be going to a.com. So that's the live coding part of it. Not much, but there's still some room for mistakes. Okay, and I want to read it as text because that's what HTML is. And then I would use, I don't know, some regular expression. But for now, let's just log it here and see what happens. Who thinks it will work, this technique here? That I will be able to read this HTML here? Raise your hand. Okay, so about 10 to 15 people. Who think it will not work? Okay, 20 people. I'm pretty sure there's more of you than 40 or 50. But let's not force you to decide. I will just show you. Let's refresh that, or we should actually refresh the attacker's page. We can see the page source. Yeah, we have this. I actually didn't run this function here. Yeah. Okay, so now I run it and refresh it here. Okay, so this request failed. So bravo, you guys who knew that. And what we get here is no access control allow origin header is present on the requested resource. And this is what I said on the beginning, that SameOrigin policy does not allow reading data across origins. So it cannot work. It's actually in IE 8, I think, before cores were introduced into the browsers, you wouldn't get this nice error with cores. This request would just not even go to the server, because this request has reached the server. It went back to the browser, and the browser did not allow this client to read it, to read the response. But actually, before cores, this request would not even go out. Yeah, but still, some very nasty developer would ask me, why can I just make this request on the server where cores no longer applies? Anyone has an idea how it would work, this attack on the server? Sorry? Yeah, right. You don't have cookies on the server. So this attack is only possible because the code executes on the browser. And that's very important that the CSRF token is dependent on the session ID. So if we do not have this session ID submitted on the server, then we don't have access to this CSRF token. Okay, so just 2 more slides. OWASP PSRF cheat sheet, Open Web Application Security Project. Strongly recommend you to read that. They go through basically every technique I know about mitigating this attack, but in short words, they still recommend CSRF token. As I mentioned, it is probably incorporated into your frameworks already. Yeah, or you can just don't use cookies. This attack is not possible in the browser without cookies. So if you're maintaining an application, you might not be able to not use cookies as easy, but in new applications, there are other solutions. And that's it. Thank you very much.